Hello and welcome to Stuff TV. I'm your host, Nick Huzar, and I'm also the co-founder of OfferUp. And I started this podcast because I was looking for answers on how my own existence impacts the planet. I found it really hard to find that online. And so I decided to start this podcast and interview really interesting thought leaders and talk about everything associated with stuff. And with me today, I've got Jonas Johnson with a company called Stellar that does a lot of construction. But within that, we thought an interesting topic would be concrete. And just before I hand it over to Jonas, I think it's worth noting that about 8% of all greenhouse gases come from concrete. And concrete is also the second most used substance on the planet next to water. And so I had no idea until I set up time for this podcast. And then also, concrete is worse for the climate than flying. Aviation accounts for about 2.8% of total global emissions. So concrete really is an area clearly for innovation and because it has such a big impact. So Jonas, thank you for being here. You're my first guest ever to do 2 episodes, so you must be special, you know. But thanks again for diving into this topic. And maybe, handing it over to you, it'd be helpful to know how, you spent a bunch of time on this. I think we were hanging out once and you were telling me all these facts that I didn't know, but, maybe starting off a little bit about your background and maybe, and also, why don't you just give us a little background on concrete?
Yeah. Well, I've been in software industry most of my life, and my career at least, and switched to real estate development a little less than 10 years ago. And, concrete doesn't sound like the most exciting topic to have on a podcast, but I found it really interesting in the fact that some of the things that you mentioned, like it's the second most consumed material in the world, second only to water, is something I think most people don't realize. And like, you think about how much of our planet is covered in this stuff, like a lot of roads, bridges, stadiums, buildings, dams, reactors. Like, I mean, it covers a substantial portion of our planet. And this stuff produces a lot of greenhouse gases as a result of producing it. So if you can either find another material or improve the way the material's made, it has a huge impact, which is why I've found it really interesting. And personally, in our company, we've been trying to build with other materials than concrete, but it literally is a very sticky material. Cement it has a lot of amazing properties. It's the reason that it's been used for so long. And so I think that it's worth spending some time talking about it, because I think it's going to be here for a long time in the future. I don't think we're going to switch to another material. I think what rather is going to happen is that we're going to find smarter and more efficient ways to build with various versions of kind of cement. Whereas right now, it's been done the same way for the last couple hundred years, and it produces a reliable product, but it can be done very differently.
Because I think you were telling me it's the same chemistry that was kind of invented from the 1700s, I believe.
Yeah, I mean, if you've ever been to Rome, like the Romans are, they were the first that kind of like used concrete at a big scale, and a lot of Rome is built out of concrete, and that was 2,000 years ago. So it's been around for a long, long time, and those buildings have been around for a long, long time. And so it's resilient. It insulates really well. I mean, like,
I can see that wall behind you is concrete.
Yeah, exactly. I mean, like, not quite, but almost a quarter of concrete is made out of water. And like, if you live near a lake or an ocean, water has a big impact on temperature. It contains temperature really well, so it's a really good medium for insulation, which is like, it's strong, it's durable, lasts long, it's cheap. You can pour it and mix it, and it dries into whatever shape that you want it to, and it insulates temperature really well. So like, it has a lot of great properties to it. Well, you start with limestone. So you have a limestone quarry where they are pulling up all this limestone out of the earth, and then you crush it, and then you put it through essentially a furnace. So the stuff has to be heated up to a really high temperature, around 1300 degrees Celsius, in order for a chemical reaction to happen.
And I think that process also produces a lot of CO2, right? That heating process.
Yeah, that's right. So, like you mentioned, 8% of all greenhouse gas emissions or come from the production of just one little tiny component of concrete that represents like 10% of the volume of concrete, which is cement. And cement is basically the glue that binds everything together with concrete. And this one little material, the glue, cement, is produced from predominantly limestone. And so you heat it up to this high temperature, and a chemical reaction happens where it releases carbon and oxygen, CO2, as part of a chemical off-gassing. So like 70% of the emissions of the production of concrete come from not the burning or the fossil fuels to heat this up or anything else. It comes from a chemical reaction that's taking place for it to become the material that we know as cement. And so after it's gone through this long furnace process that heats it up and changes the chemical nature of this, then it gets shipped out. And there are these big mega companies around the world that are huge companies, conglomerate companies, multi-billion-dollar enterprises that in a lot of ways have localized monopolies. They then sell that product to a much more kind of cottage industry, which is the concrete industry, where you see those cement trucks that go down the road and are mixing the cement in the back. Those are like the local supply chain, basically, for cement. They are buying the glue, the raw material of cement, and then locally they mix it with what's called aggregate, which is basically just like, it could be more of that construction debris. It could be rocks and sand and different things. And then it's mixed with water. And then you mix it together and it turns into that soupy liquid. And then it gets brought here and into this wall, where it can either come here in a few ways, but it can get cast in place and poured, or it can get poured into some form like a brick and then brought out to site and stacked. But it is essentially that mixing of glue with rocks and sand and water.
And I mean, that's really interesting and you think about this, when you go to different places, I'm always fascinated by architecture, and I always look at the buildings and the bricks and everything. And it's always very different. And I think it's part of that could be, as you're talking, I was thinking through this idea that concrete is kind of the glue that holds it together, but then all the other stuff that gets mixed in is more regional, right? And that's probably why when you travel a lot and you look at different buildings, that they look so different.
Yeah, right.
Yeah.
Like the color of the material can be different. Exactly.
That's because what's local. Well, when we were connecting before, we talked a lot about Turkey. I thought that was interesting, your points of view, where, oh man, it was so tragic that all those people ended up dying and all those buildings were falling. Why was that?
Yeah, I mean, I'm not an expert on Turkey by any means, so I think take it with a grain of salt. But from an outsider looking in, like the thing that makes innovation so slow in the construction industry is all this building code that is very strict. It's kind of like the equivalent of like the FDA for the pharmaceutical industry. Testing takes a long time, and it makes it really expensive to make anything new. But it also is there for a reason, because it's like people are living in these big, tall buildings, and if an earthquake hits, you want to make sure that it's not like some new experimental building method that collapses. You want to make sure that you can trust that it's going to stay erected. And so, like I mentioned, that like a fraction of concrete is that glue, cement, and building code says that you have to use a certain portion of cement in your mixture of concrete, especially if you're using it for load-bearing walls or any kind of a load-bearing, like a column. and you have to mix it with a certain amount of steel, which is the rebar, kind of gives you the skeleton of it in the center. Well, what happened in Turkey, from my understanding, is that there was some bribery that took place, and there was companies that built buildings that didn't follow building code, and they would use, because cement is the most expensive part of this mixture, and so of the individual per volume, the components, and so by subbing it out for other cheaper, essentially materials that are the glue, you can save cost. And what a lot of these buildings did is that they built to a lower specification than what was required. And when building code, somebody went to inspect it and looked at the building, and they said, "Oh, this is not built properly. It's not built to code." Nobody enforced it. And then finally, what happened is the government said, "We'll give you a penalty. So you have to pay this penalty." But the problem was that the penalty was less than the cost savings. So if you're a business person, you're trying to make just a black and white financial decision. You're like, why the F am I going to pay to put all this expensive stuff in there if I don't need to, and the building is up there and it's fine and it's not collapsing? I'm just going to take the penalty and build it cheaper. And it was like this ticking time bomb, that it was like the buildings were fine. They didn't need to use all that cement and all that rebar to keep the building erected. But until the
earth shakes,
catastrophic earthquake, there's a reason why building code said you have to do this. And and so I think it was just like a lax, forcing of the rules and some bad policy that led to this.
Hopefully that changes now after all this.
Yeah.
When you think about like where we are now, back to this, we've had the same mix since the 1700s. What are there areas of innovation, things you say, oh, I think that we can rethink things? I mean, it just seems like this is an old industry that, it's like you talked about with real estate, it doesn't move very quickly, but it seems like there's opportunities for innovation.
Yeah, I think so. we've tried using different materials to substitute out the cement, which has been really fun and interesting to watch. Things like burning rice husk. There's like another one that is accepted in most of the world, it's called fly ash, which is the byproduct of burning coal. And so these things can be used up to like 30 to 40% replace cement. And the thing that's beneficial with this is it doesn't have that off gassing that, what I mentioned, the 70% of the CO2 that's produced, you skip that whole thing by replacing it with this other material. And like now what we've realized is that these other materials don't just have the less CO2 benefit, but they also have other properties. They can cure faster. You potentially can get more strength. And so there's likely going to be more and more innovation in various types of concrete that is produced based on different applications. And we already do have this. We have different certifications based on if it's an interior wall or an exterior wall, and if it's load bearing or if it's flat work. But there is the potential for even better refinement, so that we can build things like, for instance, if you're going to build a factory and you're going to build buildings in a modular fashion, you likely want in like a highly mechanized way in a factory, you want very different properties. Like you want this to cure as fast as possible, and you're in a controlled environment where you're not out in the elements where it could be freezing or cold and you have to deal with raining, whatever. So like in a controlled environment, you don't need to build to the lowest common denominator of like what works in any scenario. You want to find the best product that works in this particular environment. And that innovation is starting to happen now. And I think, there has been huge investments now, as like countries like Norway set these like super high environmental efficiency standards from their equivalent of the EPA, and for output for all kind of industries. And in order for them to reach their target, they've invested like 1.8 billion euros to building out a carbon capture plant on one of their cement plants, and that alone is going to have, I think it's high single digit percentage change in their whole country's emissions just
Wow.
based on being able to capture some CO2 from this plant.
So it's basically ingesting carbon and then using it for, basically putting it into the concrete mix.
Exactly. Yeah.
Yeah.
And like, Bill Gates, this is like one of the things that he's most excited about when you look at the investments that he's been making. He's been pumping a lot of money into to cement. He's invested in, I think, at least a half a dozen, maybe a dozen companies that are helping to kind of decarbonize and provide innovation in this sector. So like he's invested in one, which is doing exactly what you're talking about, which is like air capture, carbon capture, and sequestration. And there's another company out of Canada that is actually able to sequester this carbon back into the concrete. So like it's likely the only way that we're going to be able to, if you're going to actually hit the Paris Climate Accord objectives of how much CO2 we need to reduce, the only way we're going to do that, I believe, is through carbon capture. But you need to figure out what do you do with this stuff. Like once you get pure carbon, where do you put it? And so like a big solution has been to essentially sequester it underground in bedrock, which is doable, but it's expensive and it's complicated and requires a lot of machinery. Another thing you could do is that we're already producing all this concrete, which you can sequester a big portion of it just back into the building material we're using. So, theoretically, it's not even theoretical. This is actually done today. This is existing. It's a product that is in the market. It's just not widely available, where you can have concrete that is a carbon sink. It was produced. All of the carbon that was created in the production was sequestered and then stored and put back into the concrete. So you actually have a carbon sink, which is pretty incredible.
Yeah, that is, again, given how abundant this substance is, and that can make, it's going to take all these different types of innovations to really, I think, move the needle. One of the things we were talking about earlier too was just what are different ways to leverage what we have to potentially create like feedstock for concrete. And one of the stats we found, I think was interesting, was 25% of demolition debris is actually diverted today from landfills or reused or recycled, according to the EPA. I was actually impressed it was that high, to be honest. That still means 75% of it all is ending up in landfills or somewhere out there. And so I still think a lot of opportunity there when you think of the waste stream in our country. Part of the challenge is everything just kind of comes into these, into recycling centers and waste management. And then it's, well, how do we isolate all these different things? And there's some really cool companies. There's one company called Glacier that I interviewed recently that do AI recycling robots, and so they're able to look very quickly as all these different materials come in and isolate the different materials and start to say, okay, this one is this type of plastic, we're gonna put it here. This is glass, we'll put it here. And so, I'm not close enough to this to know, like, is there a whole waste stream there that becomes feedstock potentially for concrete? Because you already have this abundant waste stream in our country that ideally it's already local. You can just tap into it. But I think historically part of the challenge is the juice worth the squeeze, right? Are we spending more time and resources trying to extract this than it's actually worth? But I think these are areas of innovation that are interesting. Are there things like that you find interesting as you think about the future? Like you mentioned a few different things, but what are things that kind of spark your interest in this space?
Yeah, I mean, I think you're right. It's like, we have so much of the waste that we produce is coming from these building materials that, like, you certainly can reuse a lot of it. The problem is that in a lot of areas, recycling has not, when you actually really, do the accounting of how much energy it takes to sort it, separate it, identify it, break it down, reuse it, and produce the material, you end up with more, more energy used in that process than just getting the natural resource and building it in the first place. But I think that it is certainly not an exploration in vain. Like at some point we're going to be able to do this cheaper. Maybe it's through robots, and Wally can be running around in our trash and and figuring out how we can separate all the different metals and materials. Interestingly enough, like there was, in Northern Europe, they went back and looked at how much of their garbage they had was being recycled, because they had like this super aggressive recycling plant, recycle everything. We're going to pay people to recycle. And they realized that it was like, what the hell are we doing? Like, it's actually causing more damage and costing more money to recycle it. So they're like, screw it. We're just going to burn it all. And they started just putting up these mass incineration plants. They're like, you know what? Just burn it and just turn it into basically solid sludge, and we'll just figure out what to do with that compressed.
It's like sludge. The worst. It's the worst. It's the worst thing I've ever heard. Yeah. Yeah. It's just mind blowing, because you think about the supply chains and how good we are at kind of manufacturing and agriculture. And then on the other side, we suck. But there's still great stuff there. It's just, the problem is it gets all commingled. And then it's like, well, how do you extract all these elements out?
Right.
I think this is where government just, again, needs to be more involved. But government needs to kind of wake up. And I always think the challenge is, they're just, they're 4-year cycles in most cases, or, they're pretty short. And I think to really drive systemic change here, you have to think on the lines of decades. You have to think, okay, I'm going to do this 20 years from now. What are we going to start to do today? And I just don't see a lot of people thinking like that. I mean, that's, a lot. I like Elon Musk a lot. Some people have mixed views on him. I just think he thinks like that.
There actually is a few companies that I've come across and have been trying to figure out if we can use it in our business, but that they do use recycled materials for 3D printing. And there's some cool stuff that you can do with this, where they're using like recycled wood, essentially sawdust, and where you can use recycled metals. You can use other biodegradable products that that you have in huge abundance, that are cheap or free. And they have some really great properties. And there is an area where we're just starting to touch, figuring out how this becomes consumer products. But I know of a few companies that I can't really name exactly what they're doing publicly, but that they are working on some really cool stuff that is going to be hitting consumer shelves within the next 3 years here, that are doing exactly what you're saying. They're able to get, and this is not going into a landfill and trying to sort through a bunch of stuff. This is getting directly from the source. So you're getting, a specific waste product that is coming out, and you can just take that specific waste product and then reuse it. So it becomes part of that's really what you want, like recycling to be part of the
supply chain, just an end-to-end experience. Yeah.
Right. So then it becomes a product. It doesn't become waste. It becomes a product for another industry that it can be really, and you think about the big innovation that Elon Musk had with the Boring Company. Like, his biggest innovation wasn't the drill that he made. It was the fact that the biggest cost that he realized you have when building a tunnel is you need to figure out what the heck you're going to do with all that dirt. Yeah. That's a bunch of volume of stuff. And the only thing he did is he found made a brick maker. Yeah. Basically stacked the bricks and said, hey, anybody want bricks? Here's free bricks.
Yeah. Exactly. Well, and that's what I go back to. You have to look at problems that have been around forever, and you just have to apply a different lens through them. And some things don't work. But in the case of the Boring Company, it was exactly it. I'm going to remove half the cost, and I'm just going to make bricks on site, and people can take them away from me. That's freaking genius. Everyone's probably standing there like, why didn't we think about this for the last 100 years?
And that just makes sense. Like, you're removing a cost center from one business, and then you're removing a cost center from another business, or potentially making it a revenue center for one of them. And that just makes sense like that. And I think that, to your point, is it's been a logistics problem. We haven't thought about things this way. And so it's not just doing it for environmental reasons, but it's like, this is like good business practice. Like, find cheaper materials that have the same properties or potentially better properties for what you need to do. So I think it's just going to require kind of a rethinking of the supply chain of some of the materials we use.
Jonas, thank you so much for enlightening us on this topic of concrete that, it can be a kind of, I guess, a dry topic, but overall, I learned a lot just how important this is in our daily lives and just how impactful it is to the planet. But thanks again for being here.
Yeah, thanks for your time.